Hi friends, in this video let us solve the signals and systems related question asked in GATE 2002 implementation paper. The question is the response of the system to a unit impulse. So response of the system to a unit impulse is nothing but h of t, impulse response. Even though they gave y of t, it is nothing but impulse response e power minus 5t minus 1. Whichever one of the following is the correct statement. So we have to find this whether it is steady state gain or something linear or open loop. Okay. You see for take Laplace transform by h of s, it is 1 by s plus phi shifted version, so e power minus s. Why I am finding this? I want to check steady state gain. What is steady state gain? What is the value at y is equal to infinity? Right? Okay. So what is h of s? Y of s divided by s of s. That is 1 by s plus phi. What is the input? Step input. For step input, Laplace transform is 1 by s. So output is equal to x of s, which is 1 by s. 1 by s plus phi e power minus s. We have to find what is steady state value by infinity. So I use final value theorem. S into y of s. So limit s tends to 0. S into 1 by s, 1 by s plus phi e power minus s. So it will be equal to 1 by 0.5, which is 0.2. So from this, I understand the steady state gain for step input is 0.2, it is not 0.1. This is wrong. Whether system is linear or non-linear, or if that from this we cannot find whether it is linear or non-linear. Even though if they give y of t, they can find, but they give impulse response, not output. So that is impossible to find. Right? So that is another thing. It is unstable, that is also not possible to find. Even though if you use for stability, what is the condition? Impulse response should be absolutely integrable. So if you integrate, right, so again it will become like stability and instability we can find with impulse response causality, but not okay, this is unstable in open loop that we cannot find. So option 3 is the right answer. Thank you.